All right, good morning. Welcome back to Intro to Statistics. So we are continuing our discussion with binomial distribution. So here we have problem number 9. It says high blood pressure. Okay, something close to my heart. National survey reported that 31% of adults in a certain country have hypertension. A sample of 21 students, 21 adults is studied. Okay, and then we're going to round our answers to 4 decimal places. So things that we have to worry about here. Okay, the scenarios are pretty much going to stay the same for this. Okay, so our N, how many people are they studying? Okay, they want 21 people, so N is going to be 21. Our P, we're just going to take the sample of the survey and say, okay, 21 or 31% of adults have the hypertension. And whatever they decided what hypertension is, that's what they decide. Okay, it's not like I have a little hypertension. Like, no. When I would teach this face to face, I have a lot of nursing students, and I have high blood pressure. Uh, I said, well, it's only a little hypertension, and nurses would sit there in the chairs, just look at me like, no, dude, no, got to take your meds, and they're absolutely right. So if you do, please do that. But yeah, it's you either do or you don't, depending on who has decided to define it. And since the doctors are the experts and what they're going to define as hypertension, I'm not going to argue with them because I don't know any better. I'm going to take their advice. So they've set the number, whatever this number is. If you have high blood pressure, like I think it's 140, it's probably lower now. Then technically you have hypertension. Okay, so whatever cutoff they've made, that's what it is. So it's not like I'm just a little pregnant. Like, no, you're pregnant or you're not. You have high blood pressure or you don't. Okay. So depending, and you might, that those numbers are going to dictate like how much medication you're going to be on. But we're not going to worry about like the categories. So we have 2 categories, and we're just going to assume that these people are not living with each other and are not like sharing meals. So like if one person has like puts a kilogram of salt in each meal, like they're not living with somebody else who does the same thing. Okay, so we're assuming that these people are independent. Okay, and then what we're going to say is, well, in part A, we want x is equal to 6. Okay, we want what is the probability for particularly 6 of them, the particular value of 6 to have hypertension. Okay, so what we're going to do is we're going to go to binom PDF because we want a particular value, and again our n is 21. Our probability of success, again, we're defining success is somebody who has hypertension. It's not exactly a success, but that's what we're defining it as for this. Okay, and then we have a 6 there. So we're going to go back here. We're going to go to distributions. Okay, we're going to scroll down a little bit to where it says binom PDF. Okay, that's what we want, binom CDF, PDF rather. And we're just going to type this in, 21, comma, where's comma? 0.31, you don't need the leading zero, but you can put it in if you'd like. Okay, so it's best practice. 6, and then, I need a parentheses there, not a 0. Okay, how come it won't do that? We'll just do it that way. And then the probability that of this 21, 6 of these people have hypertension. Okay, enter. We got, let's see, 0.184. We're going to change that 2 to a 3 here. So 0.1843. Here, just pulling that right off of the calculator. 0.1843. Okay, and that's the answer we're going to give. Okay, so we have 0.18443. Okay, check. Hooray. Okay, what is the probability that more than 6 have hypertension? Okay, now it gets a little bit tricky, right? So what are they asking? More than 6. What numbers are more than 6? Is 6 more than 6? I don't think 6 is more than 6. I'd like to say 7. 7 is more than 6. So we want the probability that x is equal to 7 plus the probability that x is equal to 8 plus the probability that x is equal to 9 plus the probability ... plus the probability that x is equal to 20 plus the probability that x is equal to 21. We have to add up all of these. We used to do this by hand. This was a delightful way to do this problem. Let me just tell you that. Now we're looking at this. Like, that looks like a lot of arithmetic. I don't want to work this hard. Okay. What we're going to do is we're going to say which numbers didn't we pick? Well, we didn't pick the probability that x was equal to 0, or the probability that x was equal to 1, or the probability that x was equal to anything up until the probability that x was equal to 6. We only went from 7, 8, 9, 10, all the way up to 21. So what we're going to do is we're going to remove those. We're going to say 1, because the whole thing, okay, there are going to be very small numbers. 1 minus binom CDF. We want a collection, and we want that collection to go from 0 up to 7. Okay, so we're going to say n. That's how many people we're talking about here. Probability of success 31, and we're going to go up to. Let me double check to make sure that I have this. More than 6. Actually, more than 6 would be 7, right? So up to 6. Okay, 1 minus the probability of up to 6 people have this. This was going to take care of the case of 0, 1, 2, 3, 4, 5, 6, leaving us with the rest of them. Okay, so that's how we're going to calculate these problems. All right. So again, once you are remembering how to punch these numbers into the calculator, the math isn't really the hard part. It's the translating from English that is the hard part. So we're going to say 1 minus second function distribution, okay? And we want binomial CDF because we're looking at a collection. Okay, we want the collection from 0 through 6. So we're going to type in 21, comma, 0.7% or 0.31 rather. Okay, and then the x value is 0 up to that number, so 0 up to 6. Okay, notice the 1 minus is already there, so that's all we have to deal with that. We end up with 0.48966, so we're going to say 0.4897, so 0.4897. Okay, 0.4897. Okay, 0.4897. That's what we're going to give the computer. That's what we're going to tell the answer is. Okay, and again, they are very picky, so we're going to type in 0.4897. To be careful with your rounding because they will mark you down. And since I do the quizzes through Alex, everything we're just going to obey the computer. That'll get us used to the computer alerts for the future here. Okay. What's the probability that fewer than 3? Okay, so again, see how the English is the problem here? What numbers are fewer than 3? Well, fewer than 3. So 0 is fewer than 3, 1 is fewer than 3, 2 is fewer than 3. Is 3 fewer than 3? I don't think so. I think we want 0, 1, or 2. Okay, so because the cumulative one just does 0 up to the point that we want, we're just going to say, oh, we just want binom. We want a collection of numbers, so CDF, okay, cumulative distribution function, okay, and we're going to type in, there's 21 people total, they have 31% chance, and we want up to 2 out of these 31 people. So it could be none of them, it could be one of them, it could be 2 of them, okay, but fewer than 3. Okay, and that's what we're going to type in for our calculator to get our exercise here. Okay, so let me go ahead and push this down a little bit. So we want second function distribution. Okay, we're going to go down to where it says binomial CDF because we want that collection. Okay, and then we're going to type in. It's like, well, how many do we have? We have 21. Right? Nothing. This doesn't change. Okay, we just have 21, comma, 0.31, comma, 2. That's fewer than 3. Okay, that's 0, 1, or 2. Fewer than 3. Enter. Is it what is this? 0.021809. So to whatever decimal places they want here, 0.0218. Okay, so this is going to be 0.0218. Okay, technically 2.81, but we have to stop somewhere. Okay, that's where they want us to stop. 4 decimal places, we're good. Okay, so we'll check. And hooray, we got our check mark, so we're good to go. Using the cutoff of 0.05, the cutoff is always, in academia, unusual is always 0.05. Okay, but why do we do that? Because the person who came up with this, that was Fisher. He was one of the people who did the pioneering work on all of this. He said 0.05 is unusual, and since he's got a great name for statistics, nobody bothered to question it. So he just said, oh, okay, well, the expert said it's 0.05, and since we're all following his work, 0.05 is the rule. Okay, in different companies, in different industries, you might be different for you. Okay, so don't say that it's 0.05 and it's forever and ever and ever the way that we're going to do it. You might be different. You know, if you're working with a very dangerous drug, 0.01 might be unusual. Okay, if it's got like horrific side effects, you might want to lower this. But for academia, 0.05 is considered the standard. Okay, so all this class 0.05. So using a cutoff 0.05 would have been unusual if more than 8 of them had hypertension. Okay, well, what's more than 8? Well, that would be probability that X would be 9, right? Like what numbers are more than 8? 9 plus the probability that X equals 10 plus the probability that X equals 11 plus dot 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 plus the probability that X equals, here we're going up to 21. 21. Okay. Now, as delightful as it would be to type out all of these numbers and add all of them up, we ain't got time for that. Okay, so what we're going to do is we're going to say 1 minus binom CDF, and we want to eliminate 0 through 8, X equals 0 up until 8. So we're going to say 21 point, what is this, 0.30? 0.31, 0.31. Okay, and then we're going to eliminate up to 8. So remember, it's a collection, it's CDF. Okay, please practice these, and that's going to be that. And we want to see what's the probability here. Okay, then we're going to decide. So there we go. So we're going to say 1 minus, okay, no, not the answer. 1 minus second function distribution. Okay, and we want binomial CDF. Okay, there we go. Okay, and then you have to remember that it goes 21, that's our n, comma, 0.31, 0.31, and then we're going up until 8. Okay, so 1 minus that, because we want to get rid of 0 through 8, because we don't want to add up all of these numbers. Okay, again, as much fun as this sounds like it would be, let's not do that. Okay, and we ended up with 0.1728. This is 0.1728. This is 17 cents. This is definitely bigger than a nickel. So would it be like unusual if more than? No, it would not. So since it would not be, okay, since the probability is, and then we'll go back to our calculator and let me minimize this guy. Since the probability is 0.1728, that's bigger than 0.05. Okay, so that's why it would not be. Check. Hooray, we got the green check and we are ready to go on. Okay, so I thank you for tuning in. I hope that these are not nearly as intimidating as they first seemed when we started. With a little bit of practice, they really are a little bit better, but the hard part is the English. Okay, so thank you, and I will see you in the next video. Oops.